Good evening, guys. Are you able to hear me?
Yes, sir.
Yes.
Okay, we'll get started. So what was the last topic we were seeing?
I think we were doing inverse.
We were seeing adjoints, no? So I hope you guys remember, no? How to find the inverse using adjoint. So what is it? A inverse is equal to adjoint of A divided by the determinant of A. Then we saw some properties of inverse, right? So I hope you guys remember this formula. If A is a square matrix of order n, then the determinant of adjoint of A is equal to determinant of A raised to the power n minus 1, where n is the order of the matrix. Similarly, AB the whole inverse is equal to B inverse into A inverse, right? Next. See, this one you can solve, right? Show that the when it was subjective, these kind of questions were very important. You know what they do? From using this one, we were supposed to find the inverse. At that point, they were important, but now since they have made it as an objective exam, I'm just thinking how this question can be asked. See, one thing. Read the question, no? So show that the matrix A 2, 3, 1, 2 satisfies this given equation. I hope you know how to verify, right? So first find A square, then A is there, I stands for the identity matrix. Take all these things and substitute it here. You're supposed to get a zero matrix. If you get it, yes, well and good, it is accepted. Right? Now, what they will do is, using this find A inverse is what they will ask. So if I'm not wrong, what I'm actually guessing is, using this equation, they might ask you to find the A inverse and they might expect you to obtain this expression. Okay. So they can rephrase the question like this. Find A inverse in terms of A and I. Means you need to stop it with this step. So let me tell you how to do it. Guys, am I clear till this point? So just give me a confirmation. Can everyone do this first part? A square minus 4A plus I. That you guys can do it, right? It's a simple thing. Now, how to find A inverse in terms of A and I is very simple. A square minus 4A plus I is 0. This is given. This is zero matrix, right? So how can you write A square as A square? You can write it as A into A minus 4 into A plus I in I is equal to 0. Then what we can do, we can either pre-multiply or post-multiply with A inverse on both the sides. When you do that, what are you going to get? A inverse into A minus 4 into A inverse into A plus A inverse into I is equal to A inverse into 0 matrix. Right? So you can do that, provided you can post multiply or pre-multiply with A inverse, provided the determinant of A is not equal to 0 in that problem, because we know that A inverse is equal to adjoint of A divided by determinant. So if you observe, the determinant is a non-zero value, so you can multiply it. So what is A inverse into A, guys, according to the definition of invertible matrices? Is it not I? So I into A minus 4 into A inverse into A is I. Don't leave it as 1, write it the identity matrix, plus A inverse into I is A inverse is equal to, what is A inverse into 0?
Zero matrix.
Zero, sir.
the zero matrix one, right? Now we need this A inverse. So what you do is take A inverse is equal to push these two things to the other side. You will get 4i minus A. Am I clear, guys? So that's the way you solve this problem. Okay, as I told you, when it had been subjective, these kind of problems were asked for 3 cross 3 matrix. But now it is my guess that they might give you options like this. See, they might give options like this: 4i minus A, 4i plus A, I minus 4a, I plus 4a. Which option is right? Obviously, this is going to be right. Right? Shall I proceed, guys?
Yes, sir.
Yes, sir.
Good. 14th one. This can definitely be given as an objective question. Okay. 1 minute. Before we go to 14th, do the 13th one, find A inverse in terms of A and I and tell me. That first part verification until you do it later. So what is A inverse in terms of A and I, guys? Did you get this thing?
Yes, I got that, sir.
So 5i minus A divided by 7. Okay, this is what you will get. How many of you got this?
I got the first one,
I
sir.
got it.
Okay. So A inverse will be equal to 5i minus A divided by 7. Okay. Now solve the 14th one. Find A and B such that A square plus A into capital A plus B into I is equal to 0. So first, what are we supposed? Can you guys tell me the steps to be followed? First, find a
A
square.
square.
Okay, what is a square? What did you get?
11,843.
11,843. Take this and substitute it here. Take a and substitute it here. I is 01. Sorry, 1001. Substitute. Add everything. You will get one matrix. What is that you are going to get on the left hand side? What is the answer, guys?
A equal to -4.
A is equal to
-4.
-4. Huh?
Yes, sir. And B is equal to 1.
So A is -4, B is equal to 1. Did you guys get it? Did anyone else get it? Okay, since you guys know how to solve this problem, I'm not stressing on it. 17th one. The other two also you guys can try it. Let A be a non-singular matrix of order 3 cross 3, then the determinant of adjoint of A. I've already told this. Determinant of adjoint of A is equal to det A to the power of n minus 1, where n is the order of the matrix. Answer will be
B, sir.
Yes, sir.
18th. If A is an invertible matrix of order 2, then the determinant of A inverse is equal to.
One by determinant of A, sir.
Yes, but how do you get it? How did you find it out? It's not a property or something, right? So A, you take it as A, B, C, D. Okay. So what is the determinant of A? AD minus BC. So what is A inverse, guys? What is the cofactor matrix? What is the cofactor matrix of A?
D minus B minus C. Right?
D minus
B
B minus.
minus C.
Correct? Huh?
Yes, sir.
Now see. What is the adjoint of A then? D minus C minus B A. Correct? Huh? What is the determinant of A? AD minus BC. Now what is the adjoint of A by det A? Okay. What is the
Sir, could
determinant
you
of A?
repeat?
What is determinant of A inverse? Determinant of A inverse is determinant of adjoint of A divided by the determinant of A. Is there anyone having confusion? So A inverse is adjoint of A by det A. If you take determinant on both the sides, it will become determinant of adjoint of A by det A. So what is determinant of adjoint of A? AD minus BC divided by
D minus. Inverse should be 1, sir.
it should be 1, no? What is the answer? Huh?
In the book, it's shown B, sir.
Wait, let me do it in a fresh page. A is equal to, let's check it again. A, B, C, D. Cofactor matrix of A is how much? D minus C minus B, A. Adjoint of A, D minus C minus B, A. A inverse, D minus B minus C, A. The whole divided by AD minus BC. Correct, sir? So what will be the determinant of A inverse? That is also AD minus BC only. And the denominator is AD minus BC. Cancelled, no? It's coming out as 1.
The A inverse into 1 by determinant of A inverse will be 1, right? So that's only for A inverse.
Determinant of A inverse. I'm doing it right only. No, adjoint of A is this thing. See, did I miss the logic anywhere? A is equal to AD, AB, CD. Cofactor matrix of A is D minus C minus B. Adjoint of A is D minus B minus C, A. I took the transpose, okay. So A inverse is equal to D minus B minus C, A. See, if it should have been 1 by determinant of A, then this should have been 1, but it is not coming out. Is anyone having the material or academy material in your hand?
Yes, sir.
Yeah, in that, can you go and check the NCERT solutions?
So in that also they have given us 1 by determinant of A only, sir, as the answer.
Is there proof given for it?
Yes, sir. They have shown us
So what are the
A, they have said it is not equal to 0, sir, and A inverse exists as A into A inverse, which is equal to I, sir.
Okay, A into A inverse is equal to I. So they took determinant on both the sides, sir.
Yes, sir, and they have
That's
given
right.
us for I,
Determinant
it is
of,
equal to 1.
yeah, I got it. Yeah, determinant of I is 1. I understood what they did. So determinant of A inverse should be equal to 1 by determinant. But why is that it's not working here? I took an example and I wanted to prove. Anyways, let me check this later. So the method is actually that is a property also. Okay, anyways. So we know the definition that A into A inverse is equal to I. So we know that determinant of AB is equal to det A into det B. Correct, Ada? So if I take determinant on both sides, det A into det of A inverse is equal to determinant of I. So determinant of A inverse will be equal to determinant of I is 1 divided by the determinant of A. Okay.
So I have a doubt,
option,
sir.
Please tell me.
So we can say A inverse is 1 by A, then we can just take determinant on both sides.
A inverse is equal to will be I by A, but there is no concept of division of matrices. No?
Okay, sir.
Okay, that is wrong. It is mathematically wrong. Yeah, that's right. Since you asked, I'm telling you one point. See, sometimes our brain will think like that because you'll feel that you'll take A to the other side. But remember that you're dealing with matrices, not with numbers. So in matrices, what are all the applicable operations? You can find addition, subtraction, multiplication, or division. Even if you're doing this pre-multiplication or post-multiplication with A inverse, what are the concept you need to have in your mind, guys? You can pre-multiply or post-multiply a given expression for matrix, provided the determinant of A is not equal to 0. Sharia? The determinant of A is equal to 0, then A inverse does not exist at all. So in which kind of problems am I talking about? This A square plus 5A minus I is equal to 0, right? We are doing a pre-multiplication or a post-multiplication with A inverse, no? In those problems, what is the checkpoint? You clearly need to have an idea in your mind. You need to first verify that the determinant of A is not equal to 0. It is then you can proceed. Okay.
Okay.
These are all very small points which you might miss. You will be in a hurry to solve the problem. I understand you guys will miss it. So I want everybody to make a note of it. Okay. So this is all about adjoint guys. Okay. This is all about finding the inverse using the adjoint method. And we have seen the properties also. If you observe in the study material, there will be a concept map at the end of the chapter. Okay. So I don't have a copy in my hand now. I hope you guys would have gone through the material. In that material, you will have something called as concept map. So in that concept map, there will be certain links between the topics. Since we are about to complete this chapter, I want everybody to go through that concept map before you try out problems, so that there are small points that are there that will stay in your head. Okay.
Okay.
So shall we go to the last exercise, that is applications of determinants and matrices in other branches of mathematics. Okay. So in this section, we shall discuss the applications of determinants for solving the system of linear equations either in 2 or 3 variables and for checking the consistency of the system of linear equations. So there is a term that is there. If 2 linear equations are given or 3 linear equations are given, depending on the type of solution you get. What do you mean by solution of linear equations? Guys, if suppose I'm giving you a question like this, 2x plus 3y is equal to 5, 5x plus 3y is equal to 6, something like that. I'm giving you a question. I'm asking you to solve these 2 linear equations in 2 variables. You solve it, okay. You're going to get the value of x and y, right? My question is, what is the significance of it? So what do you mean by that x and y?
So the coordinates graph, we can plot it, sir.
Yes. When you take a 2-dimensional graph, that x and y represents the coordinates of a point where, complete the statement, where
the graph for the lines equation passes through.
Where these 2 lines meet. Okay, there is nothing like, you should not say equation passes through. You should always say what that equation represents. A linear equation in 2 variables is a straight line, right? You have 2 straight lines, and if these 2 straight lines meet at real time, then you will get a real point, right? So x comma y, I can give different names to it. See, for example, if I get x comma y as, I'm taking some random value, don't verify it with the equation. Let's say we are getting it as 1 comma 2. In terms of relations, I can call it as an ordered pair. Correct? In terms of coordinate geometry, I will call it as the point of intersection of these 2 lines, where this one is called as the abscissa, 2 is called as the ordinate. That is in terms of, in the language of coordinate geometry. Similarly, in terms of linear equations, I can call it as the solution of this equation. The solution of these 2 equations. So what do I mean by solution? On solving them, I get x and y, right? So that value, depending on what that solution is going to come out, the equations are basically classified into 2 types. The system of equations, I'll not call it as equation, the system of equations. What do I mean by system? It is a collection of both these equations put together. We call it a system. So that system can be called as consistent system if its solution, what do I mean by solution in terms of this context? is the value of x comma y. If it has one or more solution, then you can say it is a consistent system. It is an inconsistent system if the system of equations does not have a solution exist. Guys, I repeat it, listen to this carefully. Based on this, I'll ask you some questions. Let me see your understanding. So when can you say the given system of equations are consistent? If they have one solution, or more solutions also. What do we mean by that? More, I'll come to that point. In a similar context, if two equations are given, two linear equations in two variables are given, they're said to be inconsistent if they do not have a solution. Correct, Ada? I hope you understood this point.
Yes.
Now we will revisit the basics of your 10th standard. You
Sir?
guys remember if... tell me, Ada.
Sir, do not have a solution means we cannot find the value of the x and y, sir.
Yes, that is the meaning. That's why I told. Just give me 1 minute time, you'll understand what I'm trying to say.
Okay.
So a to x plus b to y plus is equal to c to d. These two equations are given. You recollect the concept from your 10th standard. Even if you don't remember it exactly, it is fine. But tell me if you remember learning something like this.
Yes, sir.
Right? You would have learned something like this. These are also linear equations in two variables. There they didn't use the word consistency or inconsistency. There they would have used a different context. What do they mean? There they would have used three things.
So
Intersecting lines,
parallel and infinity. Infinity, sir.
Intersecting lines, parallel lines, or same lines. Same lines are nothing but they are overlapping on each other. Correct? Now,
Yes.
the same context, this story is given with a different name. If I have a line like this and line like this, how many solutions does it have? Two lines which are non-parallel can meet each other in a two-dimensional plane.
Unique solution, sir.
So it's a unique solution. So if this is a linear equation L1 and there is another linear equation L2, what can I say about this kind of a system of equations? Is it a consistent system or an inconsistent?
Consistent
System.
That is the meaning of definition. Now, suppose I have a line like this and I have another line like this. Okay. This is a system of equations which have
Infinite solution.
So can this be taken as consistent or inconsistent according to the statement?
Can be taken as consistent, sir.
Be taken as consistent. Then you can ask me what is the meaning of inconsistent system? You tell me.
But lines don't intersect at all.
Parallel line.
They're parallel lines. So you have a set of two lines which are parallel to each other, then you can call it as an inconsistent system of equations. Okay. The same thing spoken with a different language. Am I clear, guys? So this is all about consistency and inconsistency of the system of linear equations that are given to you. The same thing is applicable to three-dimension also. See, but I didn't go to a three-dimensional structure because this actually in three dimensions does not represent the equation of a straight line, rather it represents the equation of a plane. Okay. So depends on, I'm sorry, it can either be a straight line or a plane depending on what the coefficients are. Okay. About this, we will discuss in depth in the three-dimensional geometry. But as of now, what you do is you treat them like system of linear equations. You just look at them like a mathematical tool and try to solve them and find whether they are unique or having, whether they have unique or more solutions or more solutions. That's it. Okay. See, now we'll go to in this chapter, we restrict ourselves to the system of linear equations having unique solutions. We will not be concerned about the infinite or no solutions. Okay. So, solution of system of linear equations using the inverse of a matrix. So, what they are trying to say is, it's very simple again. It's not a very big deal. Like we have already discussed, x plus y is equal to 1, x minus y is equal to 10. Something like this is there, for example. If I ask you to solve these two equations, You can follow different methods, right? You can follow substitution method. So what do you mean by substitution?
Yeah,
You will
to
write
find
x is equal to 10 plus y. Take this and substitute it here. 10 plus 2y is equal to 1. And you will find the value of y. That is substitution. Or you can go with the method of elimination. Elimination is you will eliminate one of the variables and then you will try to find the answer for it. So these are all different. What do you call them actually? System of two linear equations is common. But the method you follow to find the value of x and y are different. So I will call them as different techniques of solving the two linear equations. So if you frame a set of different techniques to solve those equations, then out of which one of the techniques is going to be using the inverse of a matrix. What they're trying to say is we have studied inverse till now. That inverse can be used in another branch of linear equations in linear equations in two variables or three variables to solve them using the concept of inverse. That's how to solve that we are going to see. Okay, now you guys are able to understand why you are studying actually. Why is inverse important in real time, at least in terms of mathematics, right? So let us express the system of linear equations as a matrix equation and solve them using the inverse of the coefficient matrix. How to do it? Let's see. So for the time being, we'll consider a system of equations like this: a1x plus b1y plus c1z is equal to. So when you consider a standard equation, you're considering the constant to be on the other side. So there are two ways of writing it, right? a1x plus b1y plus c1z plus d1 is equal to 0. Generally, we write the line equation, the general equation of a line in this format. But here, nowhere it is referred to as line. Okay. So what they are trying to do is, if the linear equations are given in such a way that the right side is not 0, but it is a constant. Guys, I'm talking about a very important point. I hope you guys understood that. Right? Generally, when you write an equation in a 2 variable or 3 variable, which is representing a geometrical shape, especially a straight line, you ensure that the right hand side is 0. Okay. But here, they didn't mention it as a straight line or a plane or anything. They are just considering the linear equations in the format that the constant is on the right hand side. This is an important point to be noted. Only then the equations that you are going to form now are valid, or else the whole story will change. Okay. So having the concept or having the important point that the constants are on the right hand side, we will call the matrix A as A1, B1, C1, A2, B2, C2, and A3, B3, C3, where this A1, B1, C1, A2, B2, C2, and A3, B3, C3 represent the coefficients of the variables on the left hand side. Okay. Then, if I take another matrix, which is a column matrix, which represents only the coefficients, and if I take another matrix P, which represents the constants on the right hand side, then from the matrix multiplication, we will be able to understand that A multiplied with X is equal to B according to these equations. Okay. So this is from the matrix multiplication that you can multiply and see. You will get A1x plus B1y plus C1z. So A1x plus B1y plus C1z according to the given question is nothing but D1. So that is why you can write it as equal to B. Okay. So
I
this
have
is
a doubt, sir.
Please tell.
We can instead write, like, instead of A1, B1, C1, we can write A1, A2, A3, B1, B2, B3, and XYZ in a horizontal way.
Where horizontal? XYZ, you can't write it horizontally. No, if you write it like that, so you want to write like this, XYZ. You want to write them as a column
Yes,
matrix.
sir. With the A matrix as A1, A2, A3, B1, B2, B3, and C1, C2, C3 in a horizontal way.
Yeah, you can do that. No, you can do that, but multiplication is not feasible. No? Because there is a 3 cross 3 matrix. If you write it like this, it becomes 1 cross 3 matrix.
Okay, sir, I understood.
Now here it is 3 cross 1. Now you can multiply. Number of rows in the first is equal to the number of columns in the second. Yes. Sorry, number of columns in the first is equal to the number of rows in the second. Yes, you can do that. When you multiply it, what will you get? You will get a 3 cross 1 matrix. That is why you wrote it as D1, D2, D3.
Okay, sir.
Yes. Now the case 1 is, see, you guys understood that A is the coefficient matrix, X is the variable matrix, and B is the matrix with the constant. So this is a column, this is a column matrix, this is a square matrix. So we know that square matrices always have a possibility of having an inverse. So or else I can put it in the reverse. Inverse is going to exist only for a square matrix, provided it is non-singular. So in the case 1, if A is a non-singular matrix, then its inverse exists. We know this fact. Then if AX is equal to B, then what you can do is you can always pre-multiply, right? So A inverse of AX is equal to A inverse of B. Why did we pre-multiply here? Because A inverse will also be a 3 by 3 matrix. If you post-multiply, then B into A inverse will not exist. Guys, are you able to understand why we are doing pre-multiplication?
Sir, we can directly take that A to the RHS and write A inverse B, no, sir.
Edra?
Sir, if I take from the equation AX equals B, if I take A to the RHS side, then it becomes B by
That
A.
is
No,
what
sir.
I told you. Listen. That is what I told you. You should not do that because you're not dealing with numbers. See, 5x is equal to 1, x can be taken as 1 by 5 into 1, where 1 by 5 is the multiplicative inverse of 5. Okay, but there is no operation of, so see, 5x is equal to 1. You are getting the 1 by 5 on other side because you're actually dividing with 5 on both the sides. Okay, this is a different way of solving. So that this 5 and 5 will get cancelled, x will be equal to 1 by 5 into 1. Purida.
Sir, but I
So
can
when
write
you
it
deal, wait, let me complete it. When you're dealing with numbers, you have the operation of division. But AX is equal to B, there is no such operation where A can be taken to the other side. Okay, you can take any number to the other side only if it is a non-zero number. There is nothing like non-zero, like, see, you have a zero matrix, but it is not a number where you can take it to the other side. So if I am able to do something like this, then what you're saying is right. But this kind of an operation does not exist.
Sir,
So it
but
is
I can
always, tell me.
Sir, but I can say 1 by 5 as 5 inverse, no, sir.
No. 1 by 5, you can say 5 inverse, multiplicative inverse. But how did you get that 1 by 5? Because you divided with 5 on both the sides. See, what happened in your lower grades, this is what they would have taught actually. 5x is equal to 1. I would have taught this in linear inequalities last year, no? See, for example, 2x is greater than 3 now. Will you write it as x is greater than 3 by 2 like this? Or is there an intermediate step in between? Divide with 2 on both the sides. You will divide with 2 on both the sides, correct? So that this 2 and this 2 will get cancelled, then it becomes x is greater than 3 by 2. In a similar context, if Ax is equal to B, you need to divide with the matrix A to call it as A inverse. There is nothing like matrix A divided by matrix A is 1. Nobody told this. It's not, they are not numbers.
Okay, sir. Yes, sir. Yes, sir.
So that's the reason why you need to multiply. The only operation where you can take the inverse to the other side is by pre-multiplying or post-multiplying. But in this context, we are pre-multiplying it because this is a 3 cross 3 matrix and this is a 3 cross 1 matrix. If you do post-multiplication, what would happen? Then B into A inverse would have not been possible at all. It's a very simple point and nobody tells this. Okay, but if you miss this, you will do mistakes in many other problems. Another I'm trying to stress on that. Guys, can you please confirm, is everyone clear of why we are pre-multiplying? And why we are not supposed to take the A directly to the other side? Are these 2 points clear in your head?
Yes, sir.
Good. So don't do that mistake. So this will be a 3 cross 1 matrix. So that's why we are pre-multiplying. So what is A inverse into A according to definition of invertible matrices? It is I into X will be equal to A. So I into x is nothing but x. So x will be equal to A inverse of B. Means if you want to find out the value of x, y, and z, okay, then what are you supposed to do? You need to find A inverse B, not B into A inverse. Okay, you should always find A inverse first and multiply it with the constant matrix that will give you the value of x, y, z. Okay, this will actually simplify your process. That is why it is easy. Okay. Next, case 2. So case 1 we took a non-singular matrix. Similarly, in case case 1 we took a non-singular matrix. In case 2, if it is a singular matrix, then determinant of A will be 0. In this case, we calculate adjoint of A into B. So these are the steps to be followed. If adjoint of A into B is not equal to 0, then where 0 being a 0 matrix, then the solution does not exist and the system of equations is inconsistent. Whereas if adjoint of A into B is 0, then the system may either be consistent or inconsistent according as the system have either infinitely many solution or no solution. So these are the 2 steps to be followed. Okay. So if you have A as a singular matrix, then what are the steps to be followed? Then you need to find out whether adjoint of A into B is non-zero or 0. If adjoint of A into B is equal to is not equal to 0, then the solution does not exist and the system of equations is said to be inconsistent. Okay. Secondly, if adjoint of A into B is equal to 0, then the system may be either consistent or inconsistent according as the system have infinitely many solutions or no solution. Okay. Why they are telling this step is because from the previous thing we got x is equal to A inverse B, right? A inverse is nothing but adjoint of A into B or adjoint of A divided by delta, correct? Now listen to this carefully. Numerator says adjoint of A into B. So what is the first statement saying? If adjoint of A into B is not equal to 0, means if there is a finite number and determinant of A is 0 because A is a singular matrix, then finite number divided by 0 is going to give you an undefined solution. It is not defined actually, correct? You don't call it as infinity, you generally call it as not defined. Tan 90 is not defined, correct? So not defined. Then we can conclude that the solution does not exist because you don't have a real solution. Solution does not exist. In that case, you can conclude that the system is inconsistent. Whereas if you have a scenario where adjoint of A into B is equal to 0, then the system may be either consistent or inconsistent according as the system have either infinitely many solution or no solution. But as we discussed in the note, in this chapter, we are concerned only about the equations which have unique solution. So this case 1 and case 2 are needed only for your theory part. So please be careful with it. Okay, Oda? Now, we will solve the system of equations. 2x plus 5y is equal to 1 and 3x plus 2y is equal to 7. So what are the coefficient matrix stuff?
2, 5, 3, 2.
2, 5, 3, 2. Before you write the coefficient matrix, what is that you're supposed to ensure?
It should be a non-singular matrix.
Okay, okay.
Determinant of A
That
should
is
not
okay.
be 0.
That is there, but okay. Okay. Similarly, x should be
X,
x
Y.
comma y, and b will be 1 comma 7. Okay, when you're writing this matrix B, what is that you need to be careful with? You need to ensure that the constants are on the. Had the question been given like this, 2x plus 5y plus 1 is equal to 0, 3x plus 2y plus 7 is equal to 0. What will you do first? What
You
should
have to
be your
move the
first?
constants to the right hand side.
You first push the constants to the right hand side and then do it. one common mistake I've seen is they will write their b is equal to 1 comma 7. Don't do that, because I gave you the logic. How did you get a into x is equal to b? By performing matrix multiplication. Sharia? So please be very careful with it, guys. I've seen people doing a mistake in it. Then what is A inverse? So A inverse is 1 comma 11, sorry, 1 by 11, 2, 5, 3, 2. Okay. So X will be equal to A inverse into B. So multiply the A inverse with B, then you will get a column matrix. When you do that column matrix, comparing both the sides, you get X is equal to 3 and Y is equal to 1. This part, can you guys do it? So what are the steps to be followed? Find A inverse, then apply. There's not a formula actually, but okay, you can have it as a formula in your mind. Apply X is equal to A inverse into B, then you will get a column matrix. Then compare X comma Y here with whatever numbers you are getting here and here. Am I clear,
Sir?
guys?
Sir,
Tell me.
sir, the second step, 1 by 11 should be negative, no, sir?
Yeah, they have given minus.
Oh, here above step, I didn't see minus. Sir.
Yeah. Even I don't know, because I didn't calculate. I just gave the idea. Anyways, you can try it out. You know how to find it. So I'm leaving this to you. Okay, similarly, the case with this thing is also the same. Okay, that's it, guys. So we will try out one statement problem, and then we are done with this chapter. So example 29, the sum of three numbers is 6. Let the three numbers be x, y, z. So x plus y plus z is 6. If you multiply the third number by 3 and add second number to it, multiply the third number with 3 and add to the second number, we get 11. Okay. By adding the first and third numbers, we get double of the second number, 2 times y. Represent it algebraically and find the numbers using the matrix method. That's it. You can do it now. So you can write x minus 2y plus z is equal to 0. So 6, 11 and 0, they are on the right hand side. Yes, you can proceed with x is equal to A inverse B. Okay,
So
guys.
I have a doubt, sir.
Please tell me.
So the constants can never be 0, right? Like all three constants can never be 0 in this question.
No need, na. Who told? They can be.
But sir, it'll be 0 if you multiply A and B.
Yeah, that is not what I meant. See, x minus 2y plus z plus 7 is equal to 0 should not be there. This should not be the formula. But x minus 2y plus z can be 0. This is accepted.
But sir, if all three are like that, then B will be 0, 0, 0. And if you multiply A inverse with 0 matrix, the answer will be 0, sir.
You're saying all the constants cannot be 0. Huh?
Yes, sir. All constants can be 0. Right, sir?
I thought you asked that constant can never be 0. No. All the constants cannot be 0. If that is the case, then what will happen? Generally, the solution will be origin. Yeah, this I've told you many times. See, x plus y plus z is equal to 0. X minus y plus z is equal to 0. Y plus z is equal to 0. If there are any system of equations which do not have a constant, they will definitely meet at origin.
Okay, sir.
Okay. But anyways, here that kind of a system will not occur. Don't worry about that.
Okay, sir.
Okay. So I suggest you all to try out these problems. At least do a rough work and see. And if there is any problem that is troubling you, do let me know. We will solve it in the next class. Okay. So with this chapter is over, guys. I hope things were easy, right? This chapter is easy only. You guys can do it
Yes,
now.
sir.
Okay. So we are left out with only one more chapter for term 1. What is that? It is
program.
Linear programming. Right. This is the only chapter with which we are left out. So if I have to give you an outline of what is linear programming, it is exactly, it is an extension of linear inequalities chapter that you have learned last year. I hope you guys remember linear inequalities, right? So linear programming is basically an application of linear inequalities. So why we study linear programming and all those things, what is the significance and importance of it? That we'll see in tomorrow's class. There is a technique called as optimization. So that is the reason we study. We will see all those concepts tomorrow, but I'm just wondering how they are going to ask the MCQs without a graph sheet, because this chapter needs a graph sheet. But we will see. No? But first we'll discuss the chapter, then we can think of the format of questions. Okay.
Okay.
So before I conclude, is there any other doubt, guys? Is there any topic that is troubling you from this chapter which you didn't understand?
Sir, I have a doubt.
Please tell me.
If they ask us to solve a system of equations by
Your
method,
voice is-
since it's MCQ, can we like elimination?
No, they will not ask you at all. That question doesn't make sense. See, how can
Yes,
they ask you to solve? Yeah, they will not ask. They will not ask. See, they might put the question like this: using matrix method, find whether the system of equations are consistent or inconsistent. That can be asked. Okay, so you can do it with elimination. Nobody is going to check the answer unless, see, I'm not sure if they are going to ask the answer sheet also. I'm not sure about it. But let's wait and see. As of now, to my knowledge, they will not ask. So this is the first time where it is complete MCQ. We used to have MCQ in 2019-20 batch, but there also I stressed everyone to write the solution so that if in the answer sheet, when they're correcting it, no, if the teachers expect solution, you already know how to do it, but you do it as a rough work, you lose marks. So that was at that point of time. I'm not sure how it is going to be this year. Okay.
Okay,
I'm just
sir.
waiting for blueprint and all those things. After that, I'll give you a clarity.
Sir, and the exam writing on matrices and determinants, will you ask only about the reduced portions or the whole thing you have to do, sir?
No, reduced only I'll ask. I
Okay,
don't
sir.
want unnecessary things. I'll not ask. These things, the inverse using elementary operations, I'll not ask. This thing I'll not ask. What do you call? Properties of determinants will not be asked. Other than that, all other topics will be asked, but it is going to be subjective, as I already told you guys. Okay,
Yes.
it is an I'll be able to judge you guys. Okay, that's it, guys. It's simple only. Try it out. If there are any other doubts, I think the study material itself has solutions for every problem from NCERT. In spite of it, if there is any problem, you tried in different method and you want to know why it is wrong or something, please do approach me. Okay,
Okay.
that's it. Okay, I'll see you all tomorrow. Let's wind up.
Thank you,
Thank you,
sir.
sir.
Thank you, sir. Thank you, sir.